Alright, y'all, it's that time again. It's Math with Mrs. Peters, the crazy cat lady of Hiram High School. Today's topic, function characteristics, part 1. And guys, there's a lot that we're going to learn about function characteristics. First thing I want to talk about is 4 words that mean exactly the same thing and will be used interchangeably. We're going to look at a picture first, right? Here's a coordinate system, X and Y. You're used to looking at them. And we have these spots on the x-axis that we're always talking about, and those spots are called the x-intercepts. But at those specific points, y is also equal to 0, so we also call them zeros. Now, when we go to solve polynomials, and we want to look at solving functions, we're also looking at solutions. Again, these are places on the x-intercept where y equals 0. And the final word is roots. We also call them roots. So I might be talking about the roots in one sentence, and the next sentence I'll talk about solutions, and the third sentence I'll be talking about zeros. You need to memorize that these all mean the same exact thing. Now, let's look at some functions here. I've drawn some functions out. Okay, I'm going to write some generic, very generic equations. Y equals x. Okay, the degree is 1. We call this one a linear. Okay, you should be pulling this information in from Unit 2. Okay, now here's another generic. This one is cubic. Okay, the next one I bet you can tell is probably y equals x to the 5th power. It's quintic. We have septic, 7th power, and nonic, the 9th power. Now, what I want you to pull from this right now, that all of these are degree, DEG, is an odd number. The degree is an odd number. Okay? Now, I know that my leading coefficient is positive because my graph is going from the lower left and traveling to the upper right. Put that information in right here. I'm not writing it down. You have to. All right, now, turning points. What's a turning point? A turning point is where in the graph we change direction for a little bit. Okay, in a linear, we have no turning points. In a cubic, we have 2 turning points. Okay, so that's 2 PPs. Okay. In a quintic, I have 1, 2, 3, 4. So I have 4 turning points. In a septic, I have 1, 2, 3, 4, 5, 6. I have 6 turning points. And remember, this is y is equal to x to the 7th power. Hopefully you're seeing a pattern forming here. Okay, in a nonic, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 turning points, and my generic equation looks something like this. So hopefully you're noticing that there's a pattern, because of course linear has 0 turning points. All right, the number of turning points is 1 less than the degree. Or we could say the degree is 1 more than the turning points. And the maximum number of real roots is exactly the same as the degree. Okay? The maximum number of real roots is exactly, and sorry guys, I didn't fix that, the same as the degree. Okay? The maximum possible. We'll put that word in there too. Possible. Right? So let's look at some that have odd leading or negative leading coefficients. What do you notice? Well, if the leading coefficient is negative, well, they look like they're going downhill if you read them from left to right. Okay, with still same equations where this one is y is equal to negative 1x. Okay, the turning point rule didn't change. The number of turning points is still 1 less than the degree. Okay, and the maximum number of real roots is equal to the degree. Very good information that we need here. All right, now let's talk about some even degree. These are even degree. All right, even degree. So let's look at, I'll write some equations out here. Y equals x squared, y equals x to the fourth, y equals x to the sixth, y equals x to the 8. And this one over here, guys, I jumped 10. I don't know why I did, but I just did. This is y equals x to the 12th. It's dodectic. There's a new word for you, too. All right, now, let's look at the turning points. Let's see if the turning point rule works here. I have one turning point. I have three turning points. I have five turning points. I have seven turning points. I have 11 turning points. Okay? My leading coefficient is positive because they're all opening up. Okay? They all catch water if I poured water into them. Okay? The number of turning points is always one less than the degree. Okay? Or the degree is one more than the number of turning points. And the maximum possible of real roots is equal to the degree. Write that in here, please. Next thing, oh, look at these. Oh my God, they all look like if I turn all my cups of water upside down, even the really weird dodectic one. If I tried to pour water in it, it would all fall out. Well, these all have leading coefficients that are negative. These are still even degrees. Okay? Even degrees, leading coefficient is negative, all my water falls out. The number of turning points is still one less than the degree, or the degree is one more than the number of turning points. Okay, the maximum number of real roots is equal to the degree. Oh, that was easy, Mrs. Peters. Yeah, it was. So write all these interesting notes down. And the next lesson will be talking about what happens when you go left and right.